view on this Thursday. Okay. At the beginning of the class, you come in and then you put homework there before the class starts. So that's how it works. But then, what is it going to look like? I may just give you. Should not. Okay. So the directions, okay, you need to give me the direction correctly, okay? Direction of the force. So that's why I said that you need to be consistent about the direction and conduct your calculation carefully. Right. After you're done with these two cases, now we can superimpose for displacement and rotation quantities. Okay, maybe later I will just call it displacement. Okay, rotation is a subset of the deformation, the change of the displacement. So I may call it displacement quantities that include the displacement, the real displacement, and the rotation. Okay, or maybe call it deformations of. Let's put it displacement. So you can superimpose all these four, right? And then you can come up with the corresponding forces and moment at each degree of freedom, right? So this is what you will be capable of doing later on Thursday. You have rotation. Maybe this is the original configuration that we okay, you have the displacement going up to here. You have the displacement going up to here. For example, okay? The displacement and rotation. So you can find that how much force and moment you need to put this structure into this shape, this deformation. Okay, so the effects from U1 is given here that involve, that correspond, that trigger the force, this vertical force. Okay, if you apply U2, you also produce this. Okay, and then use U3 and U4 and so on. So here your F1, okay, you can constitute this F1 by 6 EI. This is upward side, right? 6, 12 EI over LQ U1. This is the effects from applying displacement U1. But F1 is also affected by the displacement, the rotation U2, which produce this 6 EI over L square U2. And then effects from U3, U4. The U3 and U4 is in your homework. For this one, you have F2 being the 6 EI over L square U1 plus 4 EI over L U2 and then blah 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 blah. Okay? Here F3 and also F4 you can do it. Okay, so once you finish the remaining two cases, you can complete the pictures of F1, F2, F3 and F4. Okay. Done. You use the same technique as I implemented yesterday. So I write force in one vector. I have one stiffness matrix and then another one displacement vector. So you will have displacement put together U1, U2, U3, U4. Inside here, in the stiffness matrix, you will have the 4 by 4. In total, 16 elements inside this matrix. Alright? And force on the other side. Okay, so the extent of this homework will be up to the constitution of the stiffness matrix for this week. Okay, that will be all. Alright, so this due on Thursday. So we will adjourn this class from this point. Okay, so see you on Thursday. Tomorrow or what? Later? Today? Whose class? Dr. what?
Professor Penham.
Here is Professor Pending's class.
Okay, so
He's not available today, so I take his spot.
And Dr. Tanagon?
Dr. Tanagon is on traveling on his trip, so he will not show today. So you have plenty of time to do this homework, all right? So you don't have anything else today. Tomorrow, Dr. Navid, please check with the secretary, but I guess Dr. Navid is on his trip also. But too bad that tomorrow I need to test my specimen. If I don't have to test my specimen, I will take his class, all right? All right, and I will not return the time for him. But okay, if we finish this class earlier, then okay, they can take the time slot for this one. And also Friday, as you will have concrete technology, so I will see what time on Friday? In the afternoon, but I'm not sure. What?
On Friday, 1:30 to 3.
1:30 to 3. Okay. Yeah, I let you know maybe on Thursday. I may take that spot again, so I can give
We
you.
have 2 classes on Friday.
Which one? Dr. Navid in the morning, right? Advanced concrete structure.
Dr. Navin in the morning.
Okay, but Dr. Navid might come back already on Friday. But Dr. Thanapon may not, so I may use that time. Okay, alright.
the F3 will be down.
Huh?
This F3 course.
Huh? What?
This F3 will be upward.
F3, the sign convention we set up initially, we have force going upward, moment positive sense of moment, following right hand rule out of plane like this. So if you end up with something downward, then you gotta change the sign to be minus something, okay? So you are following the positive sign convention. Alright? Okay, have a good afternoon.